Okay, this is the solid-state Bedini Pulser hitting this HHO cell. This is a, yeah, here we go. Clamp on. That's the positive side, by the way. So we're getting negative pulses into the positive side. That's the frequency it's on. That's all right. So this is what the cell is seeing. 12.05. This is an analog version of that same reading. This is a Simpson meter. It's about as good as you can get. 12 volts. This is the gas production. See, it's bubbling right there. And this is the DC input. It's about 3 volts. And that's the AC watts right there going into the variac, which is feeding a battery charger. And the battery charger is sitting, that's about 3 volts, something like that. The amperage is, what is that, 10 something. This is what the variac is putting into that thing. It's not even 60 some volts. Okay, this is the frequency it's running right now. That's 317 hertz. And what's that reading here? This is the rate. It's on 1K. Yeah, we put a 10-turn pot inside this. We modified this BK here because that's one of the weaknesses of this unit. Didn't have any 10-turn pots for the width and the rate. And this is the width right here. 50, what is that? 500 microseconds. And the level is just barely on. We're hitting it with the it's a signal amplifier. Amplifies the amperage. It's being powered by about less than 10 volts. It's a Darlington pair. The schematic for that is on my website, leblancinventors.org. You'll see it. Go to the news under R&D, and then a drop down from R&D, it'll say news. Go to the news. You see the schematic will be in there. So there you have it. And the cell is sitting at about 55 degrees. So the internal resistance of the cell at 55 is about 1.3 ohms. You got to get it hot before that thing will do about 0.5 ohm. So there you have it.